Hello and welcome to helpyourmath.com. In this video, we're going to take a look at polynomial long division. This is a strategy we might have to use because of certain restrictions on dividing. So maybe we can't factor the dividend, or we have a leading coefficient of the divisor, or the divisor is not linear. Before we get started with all of that mumbo jumbo that I was just talking about, we're going to start with just regular numbers. How do we do long division with regular numbers? Well, the way that I learned it was we put the divisor, that's the one that's doing the dividing, outside on the left, and we put the dividend, the one that's being divided into, under my little two-sided housey thing. Very technical vocabulary here, I know. And then we say, okay, 84, the divisor, doesn't go into 9, so we skip the 9 and we go to 97. 84 goes into 97 one time. 1 times 84 is 84, so we're going to subtract 84, leaving behind 13. Then we bring down the 2, and now we say, okay, well, how many times does 84 go into 132? This also happens to be 1, because if there were two 84s, it would be at least 160. And then I say minus 84, and then when I subtract, I get 1, I get an 8, and then 12 minus 8 is 4. So the way I would write this is I would say this is a quotient of 11 with a remainder of 48 over 84. So we take the remainder, that's what this thing's called, and we write it as a fraction over the divisor. So we take the remainder, we write it as a fraction over the divisor. This here, this 11, is the quotient. Now, I'm not totally done yet in this case because 48 and 84 have a common factor. Actually, a few common factors. They're both divisible, the largest of which is 12. So I can take that fraction of my mixed number and divide by 12 over 12, and that would give me 4 over 7. So now my final quotient with its remainder is 11 and 4/7. Let's look at one more example. Hopefully we don't have an 11 and we have something a little more interesting. We take the divisor, 43. We put it on the left. We take the dividend, 1062. We put it in the little house deal. Then we say, okay, 43 doesn't go into 1. It doesn't go into 0. It does go into 106. Let's see. I think it's going to be twice, so I'm just going to set up my multiplication here. I get 86. Could I do better? No, I don't think I can do better. And I'll be able to verify that I can't do better in just a minute. So then I put the 2, that's part of my quotient, up at top, over the divisor, specifically over the very last digit that I'm looking at. So I'm only looking at this 106. So I put the 2 over that 106. I multiply. 2 times 43 is 86. And then I subtract. This would be 20. Okay. So I said there would be a way to know if I was wrong with the 2. This is called the partial quotient. The partial quotients should be less than the divisor. If they're bigger than the divisor, you didn't choose a big enough number for the quotient. Go back and try again. But since 20 is less than 43, I did okay. We bring down the next digit, which is a 2. 43 goes into 202. Gosh, I think 5 is going to be too big, so let's look at 4. It's 172. That looks good. Okay, I buy that. And we put the 4 there. And then again, we would take the 4 and we would multiply it by 43, which gives me 172. When I go to subtract, I have 30. So 30 is my remainder. And I would say that 1062 divided by 43 is 24, the quotient, with a remainder of 30, which we put over 43. You might be asking yourself, okay, this was supposed to be a video on polynomial long division. You just showed us numbers. What was the purpose? The point is that we use the same technique over and over again. So we set it up the same way, and then there's a lot of similarities where we're going to multiply, subtract, bring down, multiply, subtract, bring down. In our first example, our dividend is x squared minus 5x plus 8, and our divisor is x minus 3. One of the differences between polynomials and regular numbers is that if there's a place missing from a regular number, like in this number 1062, I put a 0 in the hundreds place to serve as the placeholder. We don't necessarily see that with polynomials. So if a place was missing, like let's say we had x cubed minus 5x plus 8, this polynomial is missing an x squared because we want the polynomial to go, for the exponents to go 3, 2, 1, no variable at all. What we would do in this case when we're setting up the long division is we would write this as x cubed plus 0x squared, right? Because there is no x squared. We actually want to physically put that in, minus 5x plus 8. It is possible to divide without doing that step, but it does make it a little bit more coherent and clear when we go through the motions. Okay, so we're going to set this up the same way we did with the numbers. I take the x minus 3 to the divisor. I put it to the left of my fraction bar deal. And then I'm going to fill this, and I'm going to use the x squared, not this one, right? That was just an example. Okay, now, what we do is we start with the term with the biggest exponent. So in this case, the biggest exponent of my variable is just that 1, the x. And I jump to what would I need for x to be exactly the same as x squared, only using multiplication. So x times blank would equal x squared. I would just need a factor of x. And that's how I'm going to start this, but because there are two terms in my divisor, I'm going to go to the second term and line up the x over the second term, the minus 5x. And then what did I do? I took that piece of that quotient and I multiplied it by the divisor. Right? Usually with the numbers, we did the multiplication ahead of time to check it, but here we're going to multiply by distributing. And I'm going to put the result right underneath where it's like terms. What did we do next? We subtracted. The whole thing that we just wrote down gets subtracted. What does subtracting do? It changes the signs. So this x squared will become a negative if I distribute the negative, and this minus 3x becomes a plus 3x when I distribute the negative. I like distributing the negative because now I don't have to look to the left to that subtraction. I'm just going to do that property of subtraction that says I can rewrite subtraction as addition by adding the opposite. Once I've done that step, now I'm going to add straight down. X squared and negative x squared canceled. That was the whole goal of this, was to get those to cancel. Negative 5x plus 3x, right? This is now a positive 3x, is negative 2x. And then we're going to bring down the next term, plus 8. Now we repeat the process. Now I'm trying to get x from my divisor to match exactly negative 2 times x. So what could I multiply x by so that it matches that first term of the partial quotient exactly? A minus 2. So I put a minus 2 up here in my quotient, and now I'm going to multiply the divisor by minus 2. Minus 2 times x is minus 2x. Minus 2 times minus 2, well, a negative times a negative is positive, and 2 times 2 is 4. Let's not forget what we do with this in division. This is subtraction. Just like I did the first time, I always suggest changing the sign so that minus 2x becomes a plus, that positive 4 becomes a negative. Once you change the signs, you've completed this subtraction, it becomes addition. Now we add going straight down. Negative 2x and 2x, that's 0. 8 and negative 4 make 4. There's nothing left to bring down, so 4 is my remainder. The way that we write it, since this is a polynomial, is we're going to take the sign, it's a positive 4, so we're going to say plus the remainder over the divisor. So my final quotient and remainder here is x minus 2 plus 4 over x minus 3. I know these are a lot to process. Let's look at another example. Okay, so in our next example, the numerator is called the dividend and the denominator is the divisor. We want to make sure that both the dividend and the divisor have the exponents going in decreasing order without skipping over any terms. So we check the exponents 3, 2, 1, no a, good. And the denominator, we just have the linear factor, so we're all good. We're ready to go ahead and set up our long division. So we're going to say 3a minus 5. That's the divisor. And then I'm going to make a really long bar. I might even have to extend it. Let's see. 6a cubed minus 13a squared minus 4a plus 15. And now we start the dividing process. We always focus on the first, so I'm taking that 3a, and I always want it to match the first term of wherever I am in the quotient. That way, when I go to subtract, those will cancel out. If I'm not sure, because I'm trying to get 3a to match this 6a cubed, I can always just go off to the side, just like I did with the numbers, although here I will divide, whereas with the numbers I multiplied. But here I can say, okay, well, the quotient needs to be 6a cubed divided by 3a. 6 divided by 3 is 2. and a cubed divided by a, that's 3 factors of a, divided by 1 factor of a, leaves behind 2 factors of a. The 2a squared, this piece of the quotient, will line up over the second term that I'm going to be working with, so that 2a squared. Now I take that piece of the quotient and I multiply it using the distributive property to the divisor. That leaves me with 6a cubed minus 10a squared. Right now, these terms on the left should match exactly. That way, when I go to subtract, they will cancel out. I do need to make sure that this piece does get fully subtracted, so I'm going to use that subtraction property and change the signs. That, adding the opposite is the same. Subtraction is the same as adding the opposite. So this negative 10a squared becomes a positive. I fulfilled this subtraction. Now I can just focus on the individual terms. When I go to combine 6a cubed and negative 6a cubed, that makes 0. Don't need to worry about that term. Negative 13a squared and 10a squared makes negative 3a squared. And because I have 2 terms here, I'm going to bring down 1 more term so that they have the same number of terms. Now I'm going to do this process again. Take the first term of that partial quotient and divide it by the first term of the divisor to figure out the next piece of the quotient. Negative 3 divided by 3 is negative 1. A squared divided by a is just a. We could just say is negative a, or you can keep the 1 in, it doesn't matter. And we're going to take that part of the quotient and multiply it to this 3a minus 5. That will give me minus 3a squared. And then a negative times a negative is plus 5a. This whole thing needs to get subtracted. So let's distribute the subtraction sign. This becomes a plus. This positive becomes a negative. I fulfilled the subtraction. I can now write it as addition. When I go to combine, negative 3a squared and 3a squared cancel out. Negative 4a and negative 5a make minus 9a. Bring down the last term, plus 15. Okay, this is the last piece of the quotient. Let's find out if there's a remainder. We're going to take that first term from the partial quotient and we're going to divide it by the first term of the divisor. Negative 9 divided by positive 3 will be negative 3, and a divided by a is 1. So my last piece of the quotient is minus 3. I'm going to take the minus 3 and multiply it to 3a minus 5. That's going to give me minus 9a plus 15. I set this up. I prepare for subtraction. I'm going to change my signs. This becomes a plus. This becomes a minus. That subtraction becomes a plus. And what happens here? This is 0, but so is this. We have no remainder. What? No remainder. So what does this mean? This means that 3a minus 5 is a factor of 6a cubed minus 13a squared minus 4a plus 15. We had no remainder, so it's actually a factor of that degree 3 polynomial. So we're going to write our final answer, 2a squared minus a minus 3, exactly this. Okay, it's your turn. Pause the video, see how you do. Were you super careful with this first one? Because what do you notice about the exponents of the dividend? 3, 1, 0. We're missing a 2. What we need to do is we need to put that plus 0x squared right smack dab behind the 2x cubed. It is possible to do this without that extra step, but it does make it more clear and manageable, I think, in my opinion. We're going to set this up. X minus 5 is my divisor. And 2x cubed plus 0x squared minus 3x plus 2 is my divisor, goes under the division sign. And now we divide. X, to make it 2x cubed, I would need 2x squared. I'm going to line it up since there are 2 terms, line it up over here, and I need 2x squared. And again, if you have to go off and say 2x cubed divided by x, you can go ahead and absolutely do that. That's going to give you that 2x squared. Next up, we multiply 2x squared times x minus 5. That will be 2x cubed minus 10x squared. This whole thing gets subtracted. And we know I'm going to change the sign, so that's going to be a minus, and this will become a plus, and then this is a plus. And then we combine 2x cubed and negative 2x cubed are 0. Good, perfect. 0x squared plus 10x squared is 10x squared. Bring down that next term, minus 3x. I need the first term of the divisor, x, to be exactly 10x squared. So I could go up here if I need to and divide. If you can do this in your head, you don't have to show this step up here. We need to add a 10x. So 10x is the next piece of my quotient. I need to multiply it by x minus 5. That's going to give me 10x squared minus 50x. This whole thing gets subtracted. And I'm going to change my signs. That's a negative. That's a positive. That becomes a plus sign. Now I'm ready to combine. 10x squared and negative 10x squared cancel out. Negative 3x and positive 50x make positive 47x. Oh my goodness. Bring down the next term, plus 2. Okay, I need x to be exactly the same as 47x, so I'm going to have to add a 47. I'm going to take that 47 and I'm going to have to multiply it by x minus 5, my divisor. When I distribute it, I get 47x minus, I'm not sure, so we go off and we do the multiplication. That's 35. That's 20 plus 3, 235, of course. 235. This is subtraction. Let's get it set up. Let's distribute that subtraction sign. That becomes a plus, and combine. 47x and negative 47x make 0. 2 and 235 make 237. So that nice one previously, worked out. We had no remainder. Perfect. This one has a remainder of 237. Do you remember how to write it with the remainder? So we take the quotient, 2x squared. Let's make that look like a square, plus 10x, plus 47, plus the remainder, 237, over x minus 5. Beautiful. How'd you do with that one? The one thing we haven't seen yet, sorry, I didn't give you a chance to answer. How'd you do with that one? Okay. The one thing we haven't seen yet is if the remainder is negative, what we would do is when we went to write the quotient and the remainder is we would just put right here, this would become a subtraction sign. Maybe we'll see that in this next example. Maybe this one is a perfect factor. Let's find out. I see in the last example, the 6y squared minus 11y minus 14. We're not missing any terms, so that's good. We can go ahead and set this one up. We also have a dividend that's the highest variable, or the highest exponent is a square, so this should be a little bit less work, which is nice. Let's see what happens. We need 2y to match exactly 6y squared. That would be 3y, because if I divided 6y squared by 2y, I would have 3y. I take that piece of the quotient, I multiply it to my divisor. 3y times 2y is 6y squared. 3y times minus 5 is minus 15y. This whole thing is subtraction. Let's change the signs. That becomes a negative, that becomes a positive. Then I can change that to a plus. I go to combine. 6y squared and negative 6y squared are 0. Negative 11y and positive 15y make 4y. Bring down the minus 14. I don't think 2y minus 5 is a factor of this polynomial. I need 2y to be exactly 4y. So we need to multiply it by 2, positive 2. I take that positive 2 and I multiply it by 2y minus 5. That gives me 4y minus 10. This whole thing is being subtracted. So let's change the signs. Negative, positive, positive. I get 0 here, negative 4 here. Oh, I do have that negative remainder. Fabulous. And when I go to write my final quotient with remainder, I'm going to say 3y plus 2 is the quotient with a remainder of negative 4 over 2y minus 5. And this would be my final answer. These have been examples of polynomial long division. You did great. Thank you for stopping by.